Okay. Good morning, everyone. My name is Biesheuvel. I recently joined the LEC team of Linaro as an employee to work on the web server and caching technologies. I have some slides to show you what I've been up to lately in terms of analyzing the questions, analyzing the problem. The main purpose of this meeting is actually to elicit feedback, especially from the members involved, to find out if you think we're on the right track and if I should proceed in the direction I've been going for the past weeks. So we call it the web Frontend Vertical. A front end, in our definition, the front end is the part that faces the network. So if you're talking about a web server deployment, then we're not looking specifically into things like distributed storage or other specific areas, but we're trying to take the whole deployment as it sits on the network with everything that's involved in generating the web pages. The vertical means that it runs through the whole stack. The best way to approach that, we thought, was to start with zooming out, especially because you're talking about large-scale deployments in this case. So you're not talking about the boot environment of a single node or other typically singular features, but we're looking at a whole bunch of nodes working together to produce a service. I'm working on this with help of Hudson Doyle, who couldn't make it to this Connect, unfortunately. He has a strong background in the Lava testing environment, or the validation architecture that we use. And this is actually some of the, in the discussion he had with Kiko, I think. This should be our take on what we're trying to accomplish. So think of a large-scale deployment, and how would you improve that from a cost perspective by replacing some of the existing nodes, or maybe all of the existing nodes, by ARM nodes with higher power efficiency. So what constitutes performance? That's basically the next step in that reasoning. You want to deliver the same service at lower cost. That's typically what you do. So the first thing that occurred to me when I was thinking about this problem is that if you're looking at an existing large-scale deployment that is supplying some service, there is reasoning behind that why the system looks as it does. So you have some load balancers sitting on the network pipe, and then you have some reverse caches, proxies on the next layer, and having some PHP or other dynamic content systems generating the dynamic parts of the pages. This reasoning doesn't really change if you start using ARM nodes. What does change is that, typically you're using less powerful nodes, especially what we have on the market today. So in some cases, adding more nodes in parallel to handle parallel tasks is possible. In some cases it's not. And that's actually what one of the main kind of preliminary conclusions so far is that we should be focusing on latency and not on throughput. Throughput can be maintained just by adding nodes in parallel, but latency may pose a problem when you have parts of workloads that are strictly sequential. So I did some quick tests, did some, well, kicked the tire, so to speak, of some of the flat dev boards we have. So the parallel entity of a web workload is the connection. So a page may consist of a lot of different parts, the HTML, the images, some other like XML that is being retrieved in the background, and all those connections can potentially be executed in parallel. Within such a connection, there's not very much parallelism to exploit that allows to scale out. So, yeah, if a certain latency is imposed by having these phases of connection, then you can't really do better than that, other than doing it faster and running it on a faster core. This is another quick, literally apt-get install WordPress on some box. And there are some other, well, kind of findings that are interesting for, well, especially as we go forward in designing the benchmarks and the test cases. Just running Apache Bench, which is just a standard kind of command line tool. You can hit the web server with, at some concurrency level, fire requests in parallel to some origin server. And, well, the first thing that you'll find out that, well, I've put it in, I've emphasized at the top. When you start doing this, then because you're not optimizing an actual typical ARM system, you're optimizing something that people have been doing in various ways for a while. So if you start doing it a bit naively like this, the first optimization you'll find will always be the ones that have been done already 10 years ago. So of course, if you're running SSL and you're not caching the connections like a proper web service would be doing, then yeah, that takes a disproportionate amount of time. The same applies to opcode caching for PHP. I mean, everybody in their right mind is, well, maybe even using HipHop or putting caches in different places to do speedups. The other thing I noticed is that Apache Bench, while it's firing off requests in parallel, which may be served on the server end by different nodes, it's all running in the same thread. So there's contention at the Apache Bench side and not at the server side. And this may all be very obvious, but it's very relevant for the problem that we're looking into. Oh yeah, it's just Apache Bench. It fires off web HTTP requests or HTTPS requests in this case, and it's just a single thread process thing, but it can have different connections in flight at the same time.
Is your server Apache or are you running Nginx?
Apache, yeah. Yeah, in the pre-fork mode even, because that's what you get by default. So. It's just getting a feeling for the problem space, but yeah, the point is not that these numbers are not worth looking at, because you know, well, likely even the Apache Bench running on the other end is causing the problem in this case. Yeah. So what do we need going forward? One of the important things is Lava support. Currently it has no notion of running an origin server on one node and running various clients in parallel on another node. And yeah, as it says in the slide, you need, you're benchmarking the server, of course, but then you need to make sure that the nodes that are generating the requests can never be the bottleneck. So you at least need a few of them to be certain. Another thing that's relevant if we go forward with, for instance, the Calzida system, it has a shared fabric which all the nodes use. If you're doing benchmarks, especially related to latency, you want to make sure that stuff happening on the other nodes is not affecting your measurements. And this is something that we have to discuss with the Lava group that are picking this up. But yes, we really need some quite drastic changes to their system to perform the benchmarks in a meaningful way. Another thing that we noticed is that power efficiency is the main driving factor, expectedly. And if you're just measuring the performance, then of course you're getting numbers, but you're not measuring exactly what you want to improve. I mean, maybe you can improve the performance by running your code faster and doing optimizations in various places. If you start adding bigger caches, faster memory, that kind of stuff, then you will also be faster, but your power efficiency will suffer as well. So if we want to have a meaningful benchmark that we can really define the target and have meaningful comparison between the systems that we're trying to replace, then it should take this into account. And just doing the conventional kind of raw power performance benchmarking is not going to be very meaningful. So, this is what we suggest as how we should be going forward with this topic. So a typical deployment means a fully optimized system with all the kind of state-of-the-art. I mean, we should be doing what people are already doing on these kinds of deployments. Otherwise, you're measuring, you're finding optimizations that people are already doing. That doesn't make a lot of sense. I've mentioned everything else. So so everything that loads the CPU is a bit more costly on ARM. So we should look carefully into that and focus on latency. There's another session by Steve Kapper after this one about Hadoop specifically. Steve, yours on Friday, right? On the assembler dependency, so improvements that where others have already put inline assembler in their code to make it run faster. So we are already looking to specific areas where we say, okay, reducing CPU congestion just by making the code run faster. That's already under investigation. What we will be doing is get input to duplicate at least a slice of such a hyperscale deployment. Sorry? Sorry, could you speak up a bit?
I was asking, have you looked beyond doing assembler optimization? Have you looked at potentially doing offload on the GPU?
No. But the GPU and the server box,
Well, whatever will be on your hardware. Well, I mean, certainly it's already been demonstrated that they do do 2x on that with the GPU number. You know, I haven't looked at the LAN stack particularly yet, but that's something that, like maybe PHP and Java and still help. Just asking.
Yeah, that kind of wraps it up for the slides. So yeah, let's proceed with the session. Start by taking any questions. Well, yeah, the question is what we need in terms of input from the members at the moment. I think the main, so there are two things kind of blocking at the moment. One is the Lava support. The other thing is getting some input from people who are intimate with these kinds of hyperscale deployments to get a feeling for how to, well, as I said, take a slice of such a system and projecting it on the number of ARM nodes on a Calxeda box preferably, and start running benchmarks and see if we find any surprises in contention in places. But yeah.
So that challenge is going to be the selection of benchmarks.
Yes. Yeah. Yeah.
Programs which can run data DBs to drive it.
Yes.
So for example, I in our case, for example, our program is so large that we get a lot of caches. If you look at things on a small scale, like, oh, let's just find some micro benchmarks, we end up optimizing for things that just don't matter for large scale.
Yeah. Yeah.
So your selection of the actual benchmarks and those really otherwise we kind of misleading ourselves into thinking, oh, we're doing great relative to other processes, but in fact, the real deployments are much more.
Yeah. Well, that's actually what you touch on is the kind of boundary between engineering a CPU, engineering software that runs on the CPU, and engineering the whole system. Because this is a bit in the middle of those two, and what you're referring to is that the workload is maybe a lot different from what others are doing. So the question is if it's that kind of engineering, is that what you do when you take the system and build it into your network, or is it a generic a problem?
For example, latency, you're absolutely right, latency is very important, and generating good code is important. The strategy we use, for example, to generate code, optimizing code, it depends on what the problems are. If the problems are pipeline completion, it's pipeline data schedule. But if the problems are, for example, high cache misses, then we will different strategies.
Yeah.
So it's not just system as a whole, it's also the CPU and the actual code generation.
Gets influenced by this as well.
Yeah. Yeah, that's a good.
Don't you think that's kind of the second stage after you go find low-hanging fruit?
Oh yeah, there'll be plenty of low-hanging fruit. You're absolutely right. So there'll be plenty of low-hanging fruit. But later on, I know the problems are going to be these kind of.
The problems are going to be later on, looking at a real actual workload driving this thing and optimizing for the right hotspots. Right.
So just one possible area to look at is, well, two, I guess. You touched on OpenSSL. There's, at least in Ubuntu, it's even the ARM assembly optimization is not turned on.
Yeah.
But then within OpenSSL, there is Neon optimization for AES, which is in the code but not hooked into the library.
Yeah.
The other area possibly to look at is interpreted languages. There's already work on PHP for a JIT, but just on the interpreter, Perl, Python, Ruby. I think most of those have benchmarks within the package. So looking at those is probably an area of low-hanging fruit.
I'm sorry, I came in late. So this might have already been covered, but at Facebook, do you guys have synthetic workloads?
No. But we do have our own internal way that we simulate real users. We just use the mic. Yeah, so the question was, I'm sorry? In 30 minutes we have a session. Sure, let me briefly answer the question then. Yes, we do, but it's not public.
So I guess then the question is, is it a worthy goal to actually define a synthetic benchmark and have that be a Linaro, an open synthetic benchmark that you could do these system level? We have the same problems in Android of what benchmark are you actually running? And yeah, exactly.
So one of the things that it looks like would be really helpful is more the members, but particularly the users rather than the hardware vendors, actually giving us more information about exactly what they care about. As Rob said, stuff like the low-hanging fruit. There could well be things out there that we may not even consider without being told what they are. So the more information people give us about their particular workloads and what they'd like to see running faster with better latency, the more likely we are to actually do them.
Yeah. Well, the assumption is kind of that running such a benchmark would reveal that. But if you there's already the Hadoop that has been pinpointed, but the Openssl was a very easy find as well, indeed.
I'd like to add that in the power management working group, we would be interested in those workloads too. So we're modifying the scheduler for Big Little MP. And any new kinds of workloads, especially enterprise workloads, would be interesting test cases for us.
Right.
Might not be. It's just that the more variety we get in our workloads, the more coverage we can get, test coverage in general.
Okay.
I would like to ask, in web server, what web servers will be concentrating or the middleware components will be concentrating? Like in web server, Apache, Nginx, and in middleware components, PHP, Python, Perl. So are we targeting all these components or we choose specific ones?
Yeah, that's a good question. The question, for instance, is if Facebook is doing HipHop, they're not using the Zend PHP. So, we should find, we should compile a benchmark basically that is relevant enough, but doing everything at the same time is probably not so meaningful at this stage. So we'll probably start out by selecting one deployment with those components stacked on top of each other, but having things in parallel within the levels, we'll probably have to wait.
Yeah, first, I think we have to identify which components we'll be targeting.
Sorry?
So first, I think we should identify which components of web server we are targeting rather than just heading in, all the directions.
Yeah, well, mainly the area is dynamically generated content. So we don't look at the actual database, but everything that's below that up until something that may be balancing, load balancing, distributing incoming requests over several nodes. So that's all in scope. So in the reverse proxies caches that may sit in between. So that's kind of the horizontal slice that we're looking into. and then vertically have enough nodes at all these levels to to be representative of a actual system.
And one more question is like, would we be targeting source code optimization or no? Or just caching technologies or tuning options?
Sorry,
Would we be-
source code optimization?
Source code optimization of middleware components?
Of the PHP, you mean?
Yes.
Likely not. No.
So any specific reason?
Specific reason. Well, what you would end up with is a set of recommendations how someone using such a system would have to change his PHP code to make it run correctly on another kind of server. I'm not sure if that's the way we want to proceed.
Source code, PHP. Yes.
Yeah, I mean, what we're talking about here is a completely different level, right? We're talking about PHP, very abstract, dynamically typed, scripting language. That's a very, very high level compared to like C code and taking TBB like for loops and then automatically targeting GPUs, integrated graphics, and SIMD and multi-core and multi-threading. So at this level, I don't think we were anywhere near what we can do with C code yet. And I think the objective here is not to burden the web developers with parallelism, right? In fact, we don't want to do that. We want to let them be as productive as possible, keep the single-threaded sequential programming model. And there's enough low-hanging fruit from just going from the interpreter to a better JIT and applying all the good JIT technology that we know how to apply for things like Java to PHP until we get to a point where we've pushed that. Then it might make sense to introduce more programming abstractions to expose more parallelism.
Do you think there's the possibility to get into parallelism within, HipHop itself without having to expose that to the end developer, though? I mean, did you explore that?
I don't think initially there will be. Maybe if we can change things, for example, by relaxing the way memory is managed, to do some garbage collection, for example, then we can do like parallel and concurrent garbage collection, right? Then we might be able to take advantage of multiple cores in that way. But there's always this trade-off of, okay, do we use the cores to do reduce latency, or do we use them to increase the number of requests that we can serve per second, right? So that's not clear. Right? Well, I had a question actually while I have the mic. So besides what we're doing with HipHop as an example of vertical, do you have any thoughts yet or any input from any other potential customers of LAMP, what the concrete stack should look like?
No, that's actually the stage that we've arrived at now, that we need to elicit that kind of input, kind of to confirm that what I've shown on the slide is actually what we all agree on is, defines the problem well enough that we can proceed and go and try to find solutions for it.
So I had a chat with Andrew Haley a bit ago, who was doing some work with OpenJDK, and he had mentioned that they were looking for some help from Linaro to run the Java compliance test. I thought that might be an interesting workload. At least it's pretty well known, or you don't think so? Oh, okay. Oh, okay. I got it. Anyway.
I
question on Python. Do you have any optimization plans for Python? Python is going to be used in OpenStack a lot. So
Yeah, we haven't specifically looked in Python. OpenStack maybe belongs more in the distributed computing track and not so much in the web front end. But so basically, our scope is kind of limited to the nodes that are serving requests basically, and not so have any logic that is involved in generating contents for the pages, but everything that is more in the business logic area or running out of context of a request, well, at least it's not, for now it's not taken into account.
Yeah, it's maybe out of scope right now for the web server front end. If you do have specific workloads, specific things, be it like Python or Ruby or whatever, that are really important to you, best thing is probably to make sure talk to the steering committee reps and make sure that they raise it. Those are the folks who basically set up priorities. There's going to be some scope for generic optimizations all over the place, and just improvement and port work, that kind of thing. We don't have a complete list. We don't have anything approximating a complete list of what we're going to do yet. Let us know what you want.
Yeah, so the thing to emphasize is that this is really about high concurrency with very similar tasks, because all these similar requests are coming in at the same time. And I think if you're using Python to generate pages, then it's maybe a bit different than having your tasks in the OpenStack environment. But yeah, if it's relevant and it's in this area, then we should pick it up.
Compared to the Python performance on ARM, is Openssl compared to Java or GCC. So
can you talk into the microphone, because I can't hear you?
Yeah, the Python performance it's not so good. So compared to even GCC or PHP or so, okay. It's going to be affecting once we start adopting OpenStack a lot.
Okay. Yeah, so that's something that at least should be brought to attention of the steering committee indeed. So, any more questions? Okay, well, thanks for attending, and if you have any questions, then you can reach me by email. Thank you.